Hello viewers, in today's session we are going to discuss an important type of limit, that is of the form 1 raised to infinity, right? And here we'll discuss this form of the limit with the help of this example, right? So let us consider two functions f1x and f2x such that let L be the limit x tends to a f1x raised to f2x, right? So if we have two functions f1x and f2x, and the limit L is the limit x tends to a f1x raised to f2x, and if we have this condition, that is limit x tends to a f1x is equal to 1, and limit x tends to a f2x tends to infinity, then this limit L is of the form 1 raised to infinity. And in this class we'll see how these type of limits can be evaluated. So now let us take this limit as L, right? And let us consider this function as f1x, and f1x is 5 sine 3x plus cos 2x, and let us consider this function as f2x, that is 1 over x. Now let us calculate limit x tends to 0 f1x, because if we compare this limit with this one, then the value of a is given by 0. So now limit x tends to 0 f1x is given by a limit x tends to 0, and f1x is 5 sine 3x plus cos 2x. Now we can evaluate this limit, and here we have 5, then limit x tends to 0 sine 3x plus limit x tends to 0, and here we have cos 2x. So now here when x tends to 0, then 3x tends to 0. So we have here sine 0, and when x tends to 0, then 2x tends to 0. Then here we have cos 0, and sine 0 is 0 and cos 0 is 1. So we have 0 plus 1, that is equal to 1. So this condition is satisfied by this function f1x. So now let us find out limit x tends to 0 f2x, and here we have limit x tends to 0 and f2x is 1 over x. Now see this limit it tends to infinity, because when x tends to 0, 1 over x tends to infinity, or 1 over x is not defined. So this condition is also fulfilled by this function f2x. So now let us see whenever we have limits of this form, that is 1 raised to infinity, because this limit is 1 and this limit is infinity. So we have the form that is 1 raised to infinity, right? So when we have a limit of this form 1 raised to infinity, then the value of this limit L can be evaluated by using this result, that is e raised to limit x tends to a, and here we have f2x multiplied with f1x minus 1, right? So 1 raised to infinity form of limits can be evaluated by this rule. When we have limit of this form, that is limit x tends to a, f1x raised to f2x is equal to e raised to limit x tends to a f2x multiplied with f1x minus 1. So now this limit L can be written as the limit x tends to 0, and we have 5 sine 3x plus cos 2x raised to 1 over x, and this is equal to e raised to limit x tends to 0, and f2x is 1 over x, and f1x is 5 sine 3x plus cos 2x, and here we have minus 1. So now we have to calculate this limit. So now let us first consider this expression, that is cos 2x minus 1. So from trigonometry we know that cosine 2 theta is equal to 1 minus 2 sine square theta, right? So if we take this 1 to the left hand side, we have cos 2 theta minus 1 is equal to minus 2 sine square theta, and now taking cos 2x minus 1 is equal to minus 2 sine square x. So we have now e raised to limit x tends to 0 1 over x, and here we have 5 sine 3x, and here we can now write minus 2 sine square x. So now we can write e raised to limit x tends to 0, and multiplying these two terms with 1 over x, we have 5 sine 3x over x, and here we have minus 2 sine square x over x. So now we have this limit. So let us simplify it. So we have e raised to limit x tends to 0. Now here we have sine 3x over x. So multiplying the numerator and denominator by 3, we can now write here 3 times 5, 15. And here we have sine 3x over 3x. And here we have 2 sine x over x, and then we have sine x, right? Because here we have sine square x, so writing sine square x as sine x times sine x, so we can now write sine x over x, and here we have sine x. So now here we have the form that is sine theta over theta, and from elementary limits we know that limit theta tends to 0, sine theta over theta is equal to 1. So now we can write e raised to 15 times limit x tends to 0, and here we have sine 3x over 3x, and then we have minus 2, and limit x tends to 0, sine x over x, and here we have limit x tends to 0 and sine x, right? So when x tends to 0, then 3x tends to 0. So this limit is equal to 1 due to this result. Limit theta tends to 0, sine theta over theta is equal to 1. So now we have e raised to 15 times 1 minus 2 times. Here this limit is again equal to 1. So here we have 1, and here we have limit x tends to 0 sine x, and this limit is 0 because the limit x tends to 0 sine x is given by sine 0, that is equal to 0, right? So now we have e raised to 15, and here we have this term is 0. So we have e raised to 15 minus 0, that is e raised to 15, right? So viewers, the value of this limit is equal to e raised to 15. So this is how, by making use of this result, we can easily evaluate limits of this type, right? And remember, whenever we have limits of this form, limit x tends to a, f1x raised to f2x, then these two conditions must be satisfied, right? That is, limit x tends to a, f1x should be equal to 1, and limit x tends to a, f2x must be it must be tending towards infinity, or it is not defined.